We are actually going to begin by going over the first three learning objectives, which is finding the domain, wholes, and vertical asymptotes of rational functions. And we're going to do these all together because as you see, when we come down to this process here, all of the steps are connected. So starting by the definition of domain, it says from module 1, lesson 6, which was section 2.1b, one of our two mathematical commandments was thou shalt not divide by 0. So that is why in that definition, we have that q of x, that denominator, cannot equal 0 from that previous page. Therefore, and I've underlined what's important here, the domain of a rational function is all real numbers except for those that make the denominator 0. Wholes is a point in which the function does not exist. A whole exists at a point in which a function's numerator and denominator both equal 0. So we'll find out what cancels. And then vertical asymptotes, when it's in lowest form, vertical asymptotes occur where the denominator is 0. So you can see here is what makes the denominator 0, and here is also what makes the denominator 0. The difference is your vertical asymptotes are in lowest terms. So we have 5 steps to find domain, wholes, and vertical asymptotes. We're actually going to fill this out as we go through example 1. So example 1 says to find the domain, wholes, and vertical asymptotes of each rational function. So for part A, my r of x equals x over x squared plus 10x. So before we start here, the first thing that we need to do is we need to factor. We need to factor r of x. I can't factor the top here. It's just x, so it's going to come over here with me. But in the bottom, we have a binomial. And because both of these have an x in it, I'm going to take my GCF out of x. So we get x plus 10. Okay, number 2 says find the domain. I'm going to put this in all caps before you simplify, set the denominator to not equal 0. So I'm going to take my denominator here. We have x times x plus 10, and I'm going to set that to not equal 0. So my first answer is simply that x cannot equal 0. My second answer is that x cannot equal negative 10. So I already have my set builder notation. I am putting in here, we have the set of all x such that x cannot equal 0, comma, negative 10. So there is my domain. Now coming back up here, it says, if applicable, simplify and rewrite r of x in lowest terms. If the numerator and the denominator of r of x have a common factor, they will cancel. So here we have a common factor of x. So those are going to cancel. I am left with only x plus 10 in the denominator. And if everything in the top cancels, we'll put a placeholder of 1. So this right here that I have boxed, this is my rational function in lowest terms. Okay. Number 4, now we're going to find wholes. The canceled values in the step above create wholes in the graph. The coordinate of the whole are obtained by evaluating r of x in lowest terms. So because I have an x here that cancels, this tells me I have a whole when x equals 0. Now that's only half of my ordered pair. I can't just assume that the y equals 0, and in fact, most times that's not going to equal 0. So we have to get the coordinates by evaluating r of x in lowest term. So I'm going to plug that into this function right here when it's in lowest terms. So now I'm going to have y equals 1 over 0 plus 10, which gives me 1/10. So I have a whole at the ordered pair. X is 0 and my y is 1/10. Right, and then lastly, we're going to find vertical asymptotes. Once r of x is in lowest terms, now set the denominator to equal 0. So I'm going to take the denominator once it's in, again, lowest terms. We have x plus 10 equals 0. Let's try 0. Subtract that over and we get x equals -10. So my vertical asymptote is at x equals -10. Okay, and so you can see here, my domain said that x cannot equal 0 and -10. Well, why can it not equal 0? Because at 0, we have a hole. And why can it not equal -10? Because at -10, we have a vertical asymptote. Whatever my domain says it cannot equal, that's going to be made up of holes and vertical asymptotes. Now, those numbers could all be holes. They could all be vertical asymptotes, or it can be split between the two. But when I find what the domain cannot equal, it's because of holes and vertical asymptotes. Okay, let's continue on. And we got 3 more examples on the next page. So I would advise you to open up your book so you can see those 5 instructions on the previous page. And here we go. So first thing we need to do is factor. I can't factor the top. That's x plus 3. When you have x to the first, you can't factor that at all. So I'm going to take this bottom portion over here, and we're going to factor it over here because this one is a hard trinomial, meaning that a is something other than 1. So I have no GCF, so we'll go into our x. My a times c is 2 times -12. My b is -5, what adds up to b, but multiplies to ac. Pause the video if you want some more time to think about that and come up with those answers. We get -8 and 3. -8 times 3 is -24. When you add, you get to -5. So because this is a hard trinomial, I am rewriting my middle term with these two numbers here. So I have 2x squared minus 8x plus 3x minus 12. I haven't changed this at all. If I was to combine these like terms here, I would get back to -5x. So now that I have 4 terms, I'm going to factor by grouping. So here, my GCF is 2x, which leaves me with x minus 4. And then my GCF here is 3, which again leaves me with x minus 4. So now this factors to what we took out as GCFs, 2x plus 3. And then what you have in parentheses twice, it comes out once, x minus 4. All right, so we have factored. Find the domain before you simplify. Set the denominator to not equal 0. So I'm going to take this right here. And set it to not equal 0. So when I set 2x plus 3 to not equal 0, you're going to subtract your 3, divide by 2, and we're going to get x equals -3 over 2. And when I set this, or to not equal, and when I set this to not equal 0, we're going to get that x cannot equal 4. So what is my domain? My domain is the set of all x such that x cannot equal -3/2 or 4. If applicable, simplify and rewrite your function, even though this says f of x, we're talking about that function, right? So, rewrite the function in lowest terms. If the numerator and the denominator of the function have a common factor, they will cancel. Here, I don't have any common factors. Even though we have a x plus 3 and then an x plus 3 here, they're not the same because of this 2 out in front. So that means, okay, so then we can't simplify. So that means this is in lowest terms. So now step 4, find the holes. The canceled values from the step above create holes in the graph. Well, if I haven't had anything cancel here, that means we have no holes. And if you're good with just that in your notes, then that's good. But if you want to write in there, why do we have no holes? Because nothing canceled. Okay, so now vertical asymptotes is our last step. Once r of x is in lowest terms, set the denominator to equal 0. So this looks almost identical to this because nothing canceled. But instead of doesn't equal, now it equals. So we get the same things. We get that x now can equal, or x equals -3/2. And here we get that x equals 4. So we have vertical asymptotes at x equals -3/2 and at x equals 4. So as I said before, this domain is made up of these two things here. If I have no holes, I mean it's all made up of vertical asymptotes. So that's why it looks so much the same. But why can't x equal -3/2? Because we have a vertical asymptote. Why can't it not equal 4? Because we also have a vertical asymptote. Part C, we start with factoring. The top will factor, that is a difference of squares. So if you take the square root of x and of 9, we're going to get x plus 3 and x minus 3. That plus or minus makes that a -9 right there. And then because this is an easy trinomial, I don't need to go and work it off to the side. I need two numbers that multiply to your c or your AC, which is 1 times -21, and add up to your b term, which is your 4. And that's going to be x plus 7 and x minus 3. Once we have factored, now we need to find the domain. Before you simplify, set the denominator to not equal 0. So my denominator here, we have x plus 7, x minus 3 cannot equal 0. So here we get that x cannot equal -7. And here we get that x cannot equal 3. So my domain is the set of all x such that x cannot equal -7 or 3. Continuing on with our steps, if applicable, simplify and rewrite r of x in lowest terms. So here we have an x minus 3 over an x minus 3. So those cancel, and I'm left with x plus 3 over x plus 7. Find the holes. The canceled values in the step above create holes in the graph. The coordinates of the whole are obtained by evaluating your function in lowest terms. So because this canceled, this tells me I have a whole when x equals 3. So then we're going to, don't just assume my whole is at 3, 0. We now have half of our ordered pair, plug it into lowest terms to find the other half. So I'm going to get y equals, I'm plugging in 3 to both of these x's. So 3 plus 3 over 3 plus 7. So we're going to get 6 over 10, which reduces to 3 over 5. So I have my x and now I have my y. We have a whole at the ordered pair 3, 3 over 5. Okay, and now the last step, we need to find the vertical asymptotes. Once r of x is in lowest terms, find the denominator, set the denominator equal to 0. So I'm going to take this denominator that's in lowest terms and set that equal to 0. And we get x equals -7. So I have a vertical asymptote at the line of x equals -7. So again, my domain is all numbers except for these two. Why can't it not equal -7? Because I have a vertical asymptote. Why can't it not equal 3? Because I have a hole in my graph. Okay, and our last one here. Following our steps, first thing we have to do is factor. The top, we have a GCF of x. So I will factor out my x, and that leaves me with 3x plus 1. And then in the bottom, this does not factor. What is the difference between x squared minus 9 and x squared plus 9? This plus right here. If this was a minus, we could factor it. Because it's a plus, it doesn't. So I'm just going to rewrite x squared plus 9. We're going to find the domain. Before you simplify, set the domain to not equal 0. Or sorry, the denominator to not equal 0. So take the bottom, x squared plus 9, and this will not equal 0. So now solve. We're going to use the quadratic or the square root property here. Subtract your 9 over. We get x squared cannot equal -9. The opposite of squaring x is to take the square root. And this right here gives me an imaginary number. So what that tells me is there is no restrictions on my domain here. My domain is all real numbers or -infinity to infinity. So that should tell you the information right here, but we'll keep going through the process. But if we have said that the domain tells me where my holes, my vertical asymptotes are, and here I'm saying there's no restriction, that means I have no hole or vertical asymptote. But we'll keep going through. If applicable, simplify and rewrite lowest terms. We have nothing that will cancel on the top and the bottom. The canceled values, and the step above creates holes. Nothing canceled, so I have no holes. Okay, and again, why? Because nothing canceled. So then lastly, once r of x is in lowest terms, set the denominator to equal 0. My denominator is x squared plus 9. When you set it to equal 0, it's the exact same thing that we just did here, right? Subtract your 9 over. Opposite of squaring x is to take the square root. And because I get an imaginary answer here, this means I have no vertical asymptotes. So if your domain is all real numbers, it means you have no holes and no vertical asymptotes.